Welcome to section 6.5. Today we're going to be talking about trapezoids and kites. Our objectives for today are to use properties of trapezoids and to use properties of kites. Let's establish a definition for a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So, in this image that we see here, we can clearly tell that this pair of sides are both parallel. Now, trapezoids have bases, base angles, and legs. So the bases are the sides that are parallel. The base angles are, in this example, they're D and C, and A and B. And we'll go over some of the properties of base angles later on. Now, the legs are the non-parallel sides of trapezoids. So AD and BC are the legs. An isosceles trapezoid is any trapezoid who has legs that are congruent. So we see here that these two legs are congruent. We know that this side and this side aren't the legs, that these are the bases and these are the legs. Okay, we have a few theorems about trapezoids that we want to go over. Theorem 6.14 says if a trapezoid is isosceles, then each pair of base angles are congruent. So, in this example here, angle A and angle B are congruent, angle D and angle C are congruent as well. Theorem 6.15 states if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So this is kind of the converse of 6.14. So if we know that D is congruent to C, then we know that AD is congruent to BC. Theorem 6.16 states that a trapezoid is isosceles if and only if its diagonals are congruent. We know that the definition of diagonal is a straight line connecting two non-consecutive vertices. So if we draw those two and they're congruent, then the trapezoid is isosceles. In this example, we're looking at the isosceles trapezoid PQRS. We are being asked to find the measure of angle P, the measure of angle Q, and the measure of angle R. So since this is an isosceles trapezoid, and we know SP is congruent to RQ, we know that angle S is the same as angle R, and that would be 50. Now we also know that angle P is congruent to angle Q. We also know that the sum of the interior angles of a quadrilateral need to be 360. So we can represent both of these as x, since they're the same, and we'll add them up to get what x is. So we have 50 degrees plus 50 degrees plus x plus x. So I'll subtract the 100 from both sides and end up with 260 equals 2x. Divide that by 2, x equals 130 degrees. So the measure of P is 130 and the measure of Q is 130 degrees. So we've talked about the mid-segment of a triangle. Now let's talk about the mid-segment of a trapezoid. The mid-segment of a trapezoid is a segment that connects the midpoints of its legs. So this red line here is the mid-segment, and these 2 points here are the midpoints of each line. Now the mid-segment theorem from trapezoid is a little different than the mid-segment theorem for triangles. The mid-segment theorem of a trapezoid is parallel to each base. So MN is parallel to BC, and it's also parallel to AD. And now the length is 1/2 times the sum of the bases. So we represent that as the length of MN equals 1/2 of AD plus BC. Okay, now let's use the mid-segment theorem and apply it to figure out the mid-segment length of MN. So we know that the length of MN equals 1/2 the sum of the bases. So it's going to be 1/2 of PQ plus SR. So I just fill in what I know. I know that PQ is 10 and the SR is 16. When I add those two up, I get 26. So I know MN needs to equal 13. In this example, I have to find the value of x. But this example is a little different because I already know my midsegment is 17. So I can still use the midsegment formula to figure out what that x is. So I know that the midsegment has to be half of the sum of the bases. So I know my midsegment is 17, and I know my bases are x plus 15. So at this point, I just need to solve for x. So what I want to do is I want to multiply both sides by 2 to get rid of this 1/2. Multiply this by 2. Multiply this by 2. So I have 34 equals x plus 15. Subtract 15 from both sides, and x equals 19. So we're going to talk about kites and establish a definition for kites. Kites are quadrilaterals that have two pairs of consecutive congruent sides, but opposite sides are not congruent. So let's give letters to each of these vertices. So AD is consecutive with DC, and AB is consecutive with BC. We want to go over two theorems for kites. If a quadrilateral is a kite, then its diagonals are perpendicular. So in this example here for theorem 6.18, if this quadrilateral is a kite, this intersection here will be a 90-degree angle. Theorem 6.19 says that if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So in this example, C is congruent to A, but B is not congruent to D. Notice I put 2 lines here and 3 lines here. In this example, we're saying that JKLM is a kite. So let's figure out what the measure of J is. We know from the last theorem that we talked about that a kite only has one pair of congruent angles. And in this example, clearly, M and K are not that pair of congruent angles. So we know that J and L have to be congruent. So we can say these are both x. Then once again, we know that the sum of the interior angles of a quadrilateral needs to add up to 360 degrees. So we add up our x plus 70 plus 150. And we just simply solve for x. So I have 360 equals 2x plus 220. Subtract 220 from both sides, and we get 140 equals 2x, and x equals 70. And you could always double check this. 70 plus 70 plus 70 would be 210. 210 plus 150 is 360. So, we're good. Okay, in this example, we're going to go back to the Pythagorean Theorem, which we have established a little bit before, but we'll revisit it now. So, we want to remember about the Pythagorean Theorem is that if you ever have a right triangle, and you have sides A, B, and C, if this is a right triangle, you can always solve for any of these sides by using the equation A squared plus B squared equals C squared. So the reason this is relevant in this example is because the diagonals of a kite make a perpendicular right angle right here. So I'm solving for x. I know that this bottom side is 4, this top side is 3, but I want to solve for x. So I set up the Pythagorean Theorem. I know that my x is basically going to be the equivalent of c. It needs to be the hypotenuse is equaling c. So we have 3 squared plus 4 squared equals x squared. So we'll have 9 plus 16 equals x squared. We'll have x squared equals 25 and x equals 5. So we have to use the Pythagorean theorem to solve for this. And that is the end of the lesson for today. Once again, thank you, and I'll see you on the next video.